now introduce our speaker. So it is my honor to introduce Melissa Miner. She is the research specialist with UC Santa Cruz. I have interacted with her for over the last several years with sea star wasting syndrome monitoring. And so today she's actually going to talk a little bit more about the recent heat wave that we had. She does a lot of research so I guess for nearly 3 decades, Melissa has played a key role in the collection and synthesis of long-term monitoring data from rocky intertidal communities ranging all the way from Alaska down to Mexico as part of the Multi-Agency Rocky Intertidal Network, or because acronyms are fun, MARINE. Data from this collaborative effort provide a wealth of information about the structure and dynamics of these important shoreline communities and are essential for assessing impacts due to natural and human-induced disturbance events. Melissa is a research specialist at UC Santa Cruz, but works remotely from around here in Bellingham. And so I'm really curious to learn more about what the heat wave meant on our beaches. So without further ado, Melissa, take it away.
Thanks, Eleanor. And can you see the presentation okay now?
No, it disappeared all of a sudden. You need to share your screen again.
Dang it. Okay.
And by the way,
go back to Zoom. Darn it.
We'll get there. The anticipation is.
I thought I was all set. Okay, I'm just doing it on my little monitor just to be safe. Okay, does that look good now?
Yes, that looks perfect.
Perfect.
Great.
Okay. Alrighty. So thank you for that introduction, Eleanor. You actually covered a lot of the things that I was going to cover in these first slides. So as Eleanor said, I work with a group called the Multi-Agency Rocky Intertidal Network, or MARINE. And we are basically a consortium of a large number of partners from all different, coming from all different places. So federal, tribes, state agencies, including lots of universities and private organizations as well. And we're all using the same methods up and down the coast from Alaska to Mexico to monitor rocky intertidal communities. And you can see our sites are pictured here with the dots along the coast. And so what do we actually do with these sites? One of our primary methods is collecting percent cover data for foundation species. So foundation species are those that are kind of the key players in the system. So things like barnacles and rockweeds and mussels, and they form habitat for other species or provide protection or food for lots of other things. And they kind of form those distinct bands that you see in the Rocky Intertidal Zone. And we sample these communities by collecting percent cover data. And our quadrants are permanently located. So we have bolts that we actually drill into the rock so we can come back to the same spot each time and sample the same areas so that we can see how cover of these organisms and species associated with them changes over time. And then another key component of our monitoring is collecting count and size data for more mobile, typically larger and more mobile things like ochre stars, the sea star. And the way that we do this is, again, we install bolts into the rock, and we use those bolts and a meter tape to delineate the edges of these larger irregular shaped plots. And then we can come back to these same areas every time and count every individual that occurs within those boundaries and also measure them. So we get not only the population size, but also the size structure. So whether that population is made up of mostly larger adults or smaller juvenile individuals or a mixture. So what do we do with all these data? These long-term, broad-scale survey data are essential for assessing impacts from things like oil spills and marine disease events. We've used these data to help to design marine protected areas and assess their effectiveness. And then the focus of the talk today is something that we've been increasingly doing, and that's looking at impacts from climate change, such as the heat wave that we had in this past June, June 2021. So here in Whatcom County, we have one, what we call a long-term monitoring site at Post Point, and that's got that whole suite of protocols that we use, so the quadrats and the seashores. And then we also have 3 additional sites that are just focused on monitoring sea stars. And the reason we established these was because in 2014, there was a sea star wasting epidemic. So this was a disease event that's actually still ongoing, but to a lesser degree than we were seeing in 2014. But it was killing massive numbers of sea stars all up and down the coast. And so we really wanted to get a better idea of what sea star populations were doing in more locations. So we set up a site up near Cherry Point, and then one at Neptune Beach, which is monitored by the Cherry Point Aquatic Reserve Citizen Stewardship Committee. It's a mouthful, and that's in collaboration with Resources and Eleanor. And then we have a 3rd site at Larrabee, and the one at Clayton is just outside of Whatcom County. So if you were here for that June heatwave event, you know that this was no joke. It was hot, and it was really hot for several days in a row. And this was a once in a 1,000-year event, hopefully. But for rocky intertidal organisms, it was really bad news because it was perfectly timed with some of the lowest low tides of the year. And in the Salish Sea region, these low tides occurred in the afternoon. So these rocky intertidal organisms, which are really built to withstand some of the harshest conditions on the planet, they can be submerged underwater and exposed to air, and can withstand and do well under extreme temperature fluctuations. But these guys were just baking out in the sun, in the direct sun, for hours and hours every afternoon for several days in a row. So we were lucky in that we had just finished our normal annual monitoring of all of our sites in the Salish Sea right before this heat wave event occurred. So most sampling occurred anywhere from late May to mid-June. And then we received emergency funds from Washington Sea Grant to go back to our sites and collect post heatwave data to assess those immediate impacts. All right, so this is a way of looking at data that some of you may not be familiar with, but don't worry, I'm going to talk you through it. So this is called a non-metric multi-dimensional scaling plot. And this, I'm talking about the panel on the right now. And so what this is basically a map of the communities. And this is based on those barnacle and rockweed photo plot data, the percent cover data. And this method allows us to look at how similar those communities are over time. So this is when this site was set up back in 2009. Each of these numbers represents a year, a sampling year. 2009 was a little bit of a weird year because we actually didn't have our rockweed plots yet. But if we look at how the community has changed from 2010 on, you can see that it moves around a lot in this space. And the way that you interpret what's going on in this MDS plot is you look over here at this species legend, we can call it. And this is an indicator of which species are most important for driving the patterns that we see over here. And so these vectors, these lines, the length of the line indicates the strength of the contribution of each of these species. So the key players are barnacles, fucus, that rockweed, and then bare rock. And the way that you interpret that is years that fell over in this region of the MGS plot. Those were primarily dominated by barnacles. And then years that fell over here on this half, those are years where fucus was typically abundant. And then up in this quadrant, those are years where there's a lot of bare rock present in the plot. And so at Post Point, and these are just data from Post Point right now, this is the key piece of information that I want you to take away from this plot. So we've got the survey that occurred just before the heat wave event in mid-June. And then this is the survey that happened in July, so after the heat wave event had happened. And you can see that there wasn't much movement in the community there. And so if this is a little bit abstract for you, and you want to actually just see what's going on in the plots, I've pulled photos from an example plot at Post Point. So this is one of our fucus plots, and this is when we set it up back in 2010. And I've just picked some of the years. This doesn't represent all the years because the pictures would end up too small. But you can see there's lots of that rockweed present in the year that we set it up. There's still a fair bit a few years later. 2016, there's actually almost no rockweed. Lots of barnacles. When we get to 2019, the rockweed is coming back somewhat. And then these are kind of the two key photos for interpreting the heat wave potential impacts or lack of impact. So this is the survey that happened just before the heat wave event in June. You can see there's a lot of bare rock, some barnacles, very little rockweed. And then if we look at that post heat wave photo, those barnacles are still probably present under this green alga, but still lots of bare rock. And this green alga is one called ulva, and it's what we call a weedy species. So it's one that really takes advantage of disturbed habitats. It can come in, settle on newly available space quickly, but then it's not a good competitor. So it doesn't really persist for the long term. So in terms of long-term impacts, this isn't too much of a concern because it typically only persists for, maybe a few months at a time. So Post Point, this is a Whatcom County focused symposium. And so I definitely wanted to focus most of the time on Post Point, but it turns out that it's a bit of an anomaly in terms of impacts from the heat wave event. And so I want to share some of the results that we got from some of our other sites throughout the Salish Sea. So we have 4 long-term monitoring sites in Padilla Bay, another site at Manchester State Park, and then one at McDonald Cove down in Hood Canal. And we have some other sites as well, but we didn't have data processed for these sites yet. And I'm just going to use this one as an example, but all of these sites, all these other sites are showing the same patterns. And those look really different from what we saw at Post Point. So again, we've got fucus-dominated communities over here, barnacle-dominated communities over here. Here is the pre-heat wave survey in June 2021. And then about 3 weeks later, this is what the community looked like at that McDonald Cove site at Hood Canal. So really different from the earlier June survey and really different from any other survey. And these surveys started in 2014. So again, this is what we're seeing at every site except for Post Point. And if we look at photos, I'll just show you 2 here. This is the pre-heat wave survey, lots of healthy olive green fucus. And then about 3 weeks later, we've got that heat wave event, and the rockweed is crispy and brown, and a lot of it has disappeared. We've got some barnacles and bare rock in there. And so these communities were really hit hard by this heat wave event. So that was our percent cover data. So data in those quadrats. What about the sea stars? there's several things going on with these guys. They are very susceptible to stress from temperatures. And they've got this disease event going on. And so I was really curious to see whether this event had a negative impact on sea stars. And when I was walking around at Post Point and some other areas following the heat wave, I definitely saw individuals like this that had just been caught stranded during those low tide events. And they'd be flipped over by seagulls and pecked at. And so there definitely was some mortality in these ochre stars and other sea stars as well that resulted from that heat wave event. But when I looked in the crevices, the sea stars generally looked okay. I didn't see any elevated levels of disease. It seemed like by being in that crevice habitat, which is really the preferred habitat for sea stars when they're not feeding, they were protected enough from the direct sun and maybe the hottest temperatures that they were doing okay. And if we look at the data, so this is again Post Point here in Bellingham. These are sea star counts on the y-axis and time starting in 2009 to 2022. So numbers bounce around a lot. This is pretty typical for a species that is highly mobile. So this is basically just them moving in and out of those permanent plots where we sample them. But then you can see this is a major decline that happened with that sea star wasting event in 2014. And then we've kind of had a little bit of recovery, but most populations at any site in this area still have a long ways to go before they get back to pre-sea star wasting disease levels. But then the really key sampling dates that I want you to look at are these last two. So this one is the pre-sea star wasting survey, and then this very most recent one is the post. Sorry, I think I said sea star wasting. The pre-heat wave survey, and then the post heat wave survey. And you can see that there's maybe a slight decline, but really not a huge impact from this event. So that's good news for sea stars. And if we look at those three other sites where we have sea star data, and I apologize for the color change, the ochre stars are now shown in green. And you can see that all of these most recent surveys were done following that heat wave event. And you can see that there is no evidence of decline in the populations. So again, sea stars seem to be doing okay. So just to summarize, barnacles, we definitely saw some death, especially those highest, that highest barnacle zone. There was some mortality. Rockweeds, in particular fucus, which we find here, they were impacted pretty heavily by this heat wave event, but sea stars seem to be just minimally impacted by the June heat wave event. What about predictions for recovery time? So to make these predictions, we have to think about the natural history of these species. And this really comes down to how fast do they grow and how far can they travel. And the adults of most rocky intertidal organisms are stuck to the rock, so they're not going to go anywhere. So it's really the babies that is the stage where these organisms can travel to new places. And so there's a couple of things that they're important for determining or predicting recovery rates. One is, again, how fast do they grow? So whether they have a short or long lifespan. And then whether or not they are what we call broadcast spawners. So these organisms release their gametes into the water, and then if those gametes are fertilized, they turn into larvae that can then float around, sometimes for weeks at a time. And so you can have source populations where maybe you had better survivorship during a disturbance event like a heat wave. And those populations can then help to repopulate or help an impacted area recover. So for acorn barnacles, They are kind of in the best situation where they are relatively short-lived, typically just a few years, and they're also broadcast spawners. So their outcome or their likely future is pretty good. I anticipate that those guys will recover quickly. For rockweeds, they also don't live very long, but these have a what we call an animal-like life history. So their babies actually drop off the parent plant at low tide and attach to the rock not very far away from the parent. So recovery for rockweeds really depends on local survivorship. So if there were pockets of survivors, then those sites will likely recover fairly quickly. But if they were, if there was a large impact at a site, it'll probably take a while for those rockweeds to recover. And then ochre stars, they have that, they are broadcast spawners, so they can send their babies far and wide, but they live a long time. So these guys live at least 20 years, possibly longer. And they have the added impact of that sea star wasting event. So their populations were already depressed prior to the heat wave. So I think that recovery time for these guys is going to be relatively slow. And it also depends on whether the sea star wasting continues to persist in the populations.
Hey, Melissa, just a quick time check, about 2 to 3 minutes if we're going to leave time for questions.
Okay, I'm just about done. So key takeaways from this talk is that these brief but extreme weather events can have really substantial impacts on communities, on rocky intertidal communities, and recovery time really depends on the species life history and also the severity of the impact. And really critical is, if this really is a once in 1,000-year event, then I think that it's not, it's not highly concerning. I think that these communities will recover back to their sort of normal levels. But if these events continue or happen at more frequent rates, as is as is predicted by climate change, the impacts of these heat wave events, they get compounded, and so you have fewer survivors and less time in between recovery, or in between events for recovery. And then hopefully I've sold you on the value of long-term monitoring. Without knowing what was there, there's no way of assessing what was lost. And I know Bobby mentioned that as well in her talk for Dungeness crabs, that you really need those baseline surveys to be able to assess impact and loss. And so I went through a lot of stuff quickly. If you're interested in learning more about the marine program and what we're doing here in Whatcom County and also more broadly, you can check out our website at pacificrockyintertidal.org. All right, so I am going to...
Thank you for that. We have time for just a few questions. And so the first question that we have is from Kim, asking if the plots are big enough to represent the whole habitat.
Yeah, that's a great question. So those plots that we use, I would say at our site here at Post Point, they do a pretty good job of representing the habitat because it really is made up primarily of barnacles and rockweeds. We have another survey type that does an even better job of really capturing the whole site, and that's where we stretch lines across from the very highest zone to the lowest zone. But that's a survey type that we haven't been able to do yet here, and we're looking for funding to do that. So that's a good question. And so I guess my answer is they do a pretty good job, but there are better ways of capturing the entire community.
Excellent. The next question is from Rebecca. Do you think that our wet/cold weather and the landslide/feeder bluff activity this winter will have an effect that will be seen in the upcoming monitoring sessions?
I'd say the wet weather is fairly typical. So that's, I feel like that's, that's something that these organisms deal with all the time, that influx of fresh water. And so they're good at dealing with that. I don't have a good answer for the feeder bluffs. I mean, there's definitely, there can be impacts from, if there's a lot of sediment, then organisms can get smothered, or there can be scouring. So it's definitely possible, but I guess I don't have a good answer in terms of direct observations for our communities here in Whatcom.
The next question is from Bobby. Was Post Point Rocky Intertidal more resilient to the heat wave than other sites, or is it rather Post Point was already on its way to rocky character, so it was less affected by the heat wave?
Yeah, and so that really was the point that I was trying to make, is that because the rockweed was largely gone from Post Point already, there wasn't a long way for that community to go in terms of change, because the rockweed was really the thing that was most heavily impacted. And I don't have a good answer for why Post Point was an anomaly. It does get a fair bit of foot traffic, and that can be particularly harmful to rockweeds, especially when they get all dried out and brittle. If people walk on them, then they can get easily dislodged from the rock. But there are other sites that we're monitoring that have, I'd say, equal foot traffic. So it might just be that it was in one of those kind of low rockweed stages, and it will recover. But I think, this is why we need long-term monitoring to see whether these events cause an area to deviate from those natural cycles.
And this session does need to end in under a minute. So the last question is from Chris Brown. Are mussels included in the study?
Yeah, so mussels are really interesting, and there's some interesting stories associated with the heat wave that I didn't have time to get into today. We don't have mussel plots at Post Point because it's a species that is one of those weedy species that kind of comes and goes quickly. But there are some interesting things going on with mussels at Post Point that I have photos of and other observations. And then we do have plots for the California mussels in other locations. So hopefully another time I can talk more about mussels. But I guess the short answer is they were heavily impacted by the heat wave. So I can share more info later if you want to talk later, Chris.
Wonderful. Well, thank you so much. I appreciate you, Melissa, today presenting on your research and sharing it with us all. So thanks again, everyone, and see you in the next session on searching for Alexandrium and hooligans. Thanks so much.
Thanks, Eleanor.